Hello everyone, welcome to Coders Camp. We are at 17th day of February LeetCode challenge and the problem we are going to cover in this video is combination sum. So the input given here is an integer array and an integer target, and we have to return a list of set of combination of numbers that sums up to target. So here few conditions are given, that is the same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen number is different. So let's understand this with an example. So here is our given integer array which contains values 2, 3, 6, 7 and our target is equal to 7. So now we have to form combinations that sums up to target, and the condition given here is we can repeat the numbers any number of times. So let's start with having 2. So let's form our first combination with only 2. So 2 comma 2 comma 2 will sum up to 6. We don't have a 1 to make it to 7. So we can't have one more 2. So let's stick with 2's and let's see if any other number is there that sums up to 7. So 2 plus 2 is 4. We need 3 to make it 7. So yes, we have 3. So let's add, and this is going to be a combination that sums up to 7. So let's see if there is any other combination exist. If we add 3 comma 3, we have 6. We don't again have 1 to sum up to 7. Let's see if we have any other number to convert it to 7. 3 comma 4 should give us 7, but we don't have 4 here as well, so we can't add any other number to 3 that makes up to 7. So now coming to 6, 6 comma 1 is the only option that make the sum to 7, but we don't have 1 again. So let's go to the last number, which is 7 itself. So that sums up to 7. So this is again one more combination that gives us 7. So overall from the given array, we could form two combinations that gives us the sum equal to 7. So how are we going to approach this? Clearly, the problem definition said that we can use the given numbers n number of times. So in that case, we should be able to possibly consider all possible numbers in all possible ways that sums up to 7. In that case, we can either go for a recursive call that consider all possible combinations in the given array. If not, we can go for a dynamic programming solution. So now in this video, we are going to see our recursive solution. So let's dive in. So this problem is a classic example of backtracking recursive solution. So let's first see how recursion is going to help us achieve the solution. So now given array 2, 3, 6, 7 or any numbers given in the input, we have first start with any number in the array. In that way, our recursive call or our solution is going to have our first number as 2 or 3 or 6 or 7. So it could be anything. So let's first start with having 2 in our combination. This is for a single combination. So we will repeat the same set of operations to find all possible combination and add it to our list. So let's start by having 2. So in this case, our sum would become, our target is 7 here. So our target after adding 2 to our combination will become 5, because we need 5 more values. I mean the values that sums up to 5 to finish this combination. And if you consider 3 as the starting digit, then we should have 4 as our extra sum that needs to satisfy this combination. And if we have 6, then we need 1. If we have 7, then we need 0. So considering this, let's follow up with 2 itself. So considering 2 as our first number in our first combination, we can proceed our solution by having one more 2 in the combination or adding the next number. It could be 2 comma 3 or 2 comma 6 or 2 comma 7 and so on. So let's stick with 2 comma 3 as of now. So now if you consider 2 comma 3, then our sum has become 4. So in 7 we have 4, we need 3 more to satisfy this combination. If we have 2 comma 3, then the sum is 5. We need 2 to add to it to get our 7. So now again from this combination proceeding further, 2 comma 3 can be added again with another 2, or we can add 2 comma 2 with another 3, or again this also goes like 2 comma 2 comma 6 and 2 comma 2 comma 7 and so on. Let's now stick to these two combinations. By adding one more 2, we will get our sum is 6. We need to add one more to make it to 7. So we can further proceed here. But here the sum is already 7. So we have got one solution that sums up to 7 for us, and we are going to add this to our list, and we are further not going to proceed in this path because our sum is already 7. We don't have to really add any more numbers here to make it something different. So here we are stopping this loop and further proceeding with the for a deeper path here. So now we have 2 comma 2 comma 2. In that case, we need one more element to be added. So if you add 2 comma 2 comma 2 comma 2, that is one more 2 to the same combination, it is gonna give us -1 because we have 6 already. By adding 2, this is gonna become 8. Out in from our target, it is an extra 1. So in that case, the value goes in negative. So what we are actually doing is we are going to find our solution at every step. Once we find a solution, we are further going to add elements and explore from here. So here also, once you add 2 comma 3, we are going to further proceed it with 2 comma 2 comma 3, 2 comma 2 comma 6, and furthermore. So if from every list we are further proceeding by adding elements and considering whether we get our 7 or not. So if we reach some negative point or 0, because our sum becomes 0 here, we are going to backtrack from here because either we get our solution or we no longer can get our solution from this list, because by adding 2 itself it is not giving us our target. So in that case, whatever after triple 2 you add in the last position, it is not going to give us our solution. So in this case, you have to backtrack from this step and stick to your previous step and further explore only in this level. So hope you're understanding this concept. This is a typical backtracking ideology. So this is the point where we have to remove this from our list. So ideally, we'd be forming a list, adding to our array list or some data structure, and from that list we further explore further. So in that case, since we got to know that this path is no longer going to benefit us, we are going to simply remove it from our array list so that we don't have to really explore this path. So yes, this is it. Further, in the same way, we are going to explore from each and every number, and whichever satisfies our condition, we are going to add it to our list. If not, if it is going to go -1, we are simply going to backtrack and remove that set from our list. So let's go to the code now. So before getting into algorithm, let's sort the given array. Why are we doing this is, if we form a value that sums up to target, we keep adding the higher value. So if suppose we need a lesser value, we don't have to really go back and look for a solution. We always look in the forward direction. So in that case, we start from the lowest value to higher value. So let's sort the given array first. And then we have to return our result in form of list of integers. So let me declare a result variable which is going to hold our result. So now from our main method, we are simply going to call this backtrack method by passing in the variables. So yes, here comes our main ideology of the problem. So we are going to start with our target. Let's consider 7. So from 7, as we add each number, we are going to reduce our sum. So once it becomes 0, which means we found a combination, we are going to add it to our result. If not, we are going to proceed further exploring the other numbers. So first thing we are going to check is our base condition, that is if our target is equal to 0. So current is the list which is going to hold the current combination that sums up to 0. So once we form that combination, we are going to add it to our result. If not, we are going to further explore the combinations. So we are going to iterate our candidates array from the 0th index, and we are going to check if target is greater than candidates of 5. For example, if our target is 7 and the candidate is having the value 8, in that case we cannot consider that number at all. So we are simply skipping that if this condition is not satisfied. So here is the thing. We first add the number to our list and then further explore the other numbers. So usually if we have to form a sum or subarray sum, what we would do is we will pass target minus the current value and index plus plus to consider the next number. But here the problem statement says we can use that same number any number of time. So we are not incrementing it to next index. Instead, we are simply sending the same index to consider the same value again. So if this condition is not satisfied, then it will increment the loop and then the next values will be considered. So here's the step I told, that if a combination is no longer is beneficial to us, then we are going to backtrack it. So yes, we will remove the lastly added combination to our current list. So yes, this is it. Once we iteratively call and get the combination's target is equal to 0, we will add it to our list. If not, we keep adding the numbers and exploring the combinations that we could form using the given integer array. So yes, this is it. Let's give it a try. Yes, let's submit. Yes, the solution has been accepted and it runs in 5 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.